Hi everyone, thanks for joining us for a special STEAM Club Online video. This one is to celebrate Science Week, with this year's theme being ocean pollution. If you've got a Science Week booklet from one of our library branches, the video is for primary and secondary school students over the age of 8. And for this special Science Week video, I'm joined by Jasmine, and as always, I'm Matthew.
In this video we're going to talk about the ocean pollution caused by CO2 or carbon dioxide. We're going to show you in an experiment how the ocean is affected by carbon dioxide, what carbon dioxide is, where it comes from, and how you can reduce your carbon dioxide emissions. So for the experiment you will need 2 clear plastic cups, 2 smaller paper cups, some sticky tape, some bicarb soda, some vinegar, the acid base indicator that we're going to talk about a little bit later on, and a plastic lid.
Now for this part, we're going to show you how to make the acid base indicator, but to do that, we'll need to transition from inside to outside because, just like vinegar, cabbage can be very, very smelly.
And we've been told it's too sticky for the lab. To make the indicator, you will need a quarter of a red cabbage, even though it's purple, a large bowl, enough boiling water to cover the red cabbage, another small bowl, a sieve, or you can use a coffee filter and a funnel, some tongs, and then also a plate or something to cover over the bowl, just so then the heat from the boiling water gets trapped in there for a little bit. Once you have all the ingredients together, cut up the red cabbage into small pieces, and then you're going to put them in the bigger bowl. Cover them over with the boiling water. And I'll put the plate at the top. Now we're going to wait about 20 minutes, just so the red out of or the purple out of the red cabbage seeps into the water, and we're going to check back and see what it looks like in about 20 minutes or so. Okay, so we're back after 20 minutes, and I'll try and lift up our lovely cabbage so you can see the beautiful purple colour. Can you see it?
No, it won't.
Yeah, okay. Anyway, you'll be able to see it a little bit later on. So what we'll do is we'll get one of our bowls, and I don't know if Matthew might help me.
Remember, be careful, this is a 2-person job, and get your parents to do this one.
So I've got the sieve over the smaller bowl. So the sieve is just capturing all of the bits of. You can see here that what we've got left over is the beautiful deep, I don't know if you can see that still, beautiful deep. Beautiful deep purple colour. So we're going to fill that up into the 2 plastic cups that we were talking about before. Right, that's just skipping. Yep. They both have to be exactly the same. So we're going to pour the acid base indicator into one of the plastic cups. We're going to sticky tape the smaller paper cup to the side.
Now, as you can see, we've already poured the acid base indicator into the cup, and we've got our other one that we prepared earlier that is going to be our control. So what your control means is the one that sits there as the base indicator, as in you're comparing the reaction of something you're experimenting on to the one that you don't touch.
So you'll see that I sticky taped the paper cup to the plastic cup, and I have the bottom of the paper cup as close to the water as possible, but without touching it. So I've sticky taped that. You're going to have a spoon, which I can't find. Thank you, Matthew. He's just going to clean it for us because we use that one to prepare our controlled one. I'm going to put in 1.5 teaspoons of bicarb soda. You think that 1.5 will be enough?
Yeah. So it's going to be 1.5 each cup, but the one that is the control is only going to have bicarb soda, and it's not going to have the vinegar.
So we're going to see what the difference is between the two when we add the vinegar to it, because the vinegar is, I'm going to add 1 teaspoon. You can already hear it fizz, and quickly put the lid on top. See.
Now what this does is it traps the gas in. Now what we know about gas is it expands to fill the area that it's in. So by putting the lid on, we're making sure that the CO2 gas we're creating with the reaction between bicarb soda and vinegar stays inside the cup and actually interacts with the water. So with the reaction, we've seen what happens. If you can look closely, and with the camera, we will put it in a much better position for you, it has changed the colour slightly of the pH indicator. It's gone a bluer colour. Now, when you use pH indicators, you can get them in a lot of different colours. Now, the one that's most commonly used is blue, but it is quite an expensive product, and so we went with the alternative at-home makeable Red Cabbage pH indicator. But because it's much darker in colour, it's a lot harder to see the change in there. So you're going to have to do it in a well-lit room and pay attention and just be patient. Now, what's happening is the vinegar and baking soda in the cup produces carbon dioxide. The carbon dioxide then diffuses into the liquid below, the water. So because the liquid changes colour when in the presence of either an acid or base, it turns a greeny blue when the CO2 is present. This shows that an acid is present. So what's happened is the CO2 has been absorbed by the water and it results in carbonic acid, which is H2CO3. And the following chemical reaction takes place, which is CO2, AQ plus H2O equals H2CO3. Now, what is carbon dioxide and why does it do this to water? Carbon dioxide is a greenhouse gas. It is called this as it warms our planet when it is in the atmosphere. It's like what happens with you warm your plants in the greenhouse. The sunlight hits the glass, it heats up the inside, the gas gets trapped, the air, the carbon dioxide, and it heats everything up. Now, for us, how our greenhouse effect works is that the ozone layer traps in all the gases. So we trap in carbon dioxide, methane, and various other things. So that's what the lid actually was for us. It was the equivalent of our ozone layer on top. Now, as you can see here, we're bringing it a bit closer and a bit clearer, that the colours have changed a bit. So you can see that this one is a lot more red and that one is a lot more blue. While carbon dioxide is a naturally occurring gas, the problem is that we currently have too much. We have a continued increase of carbon dioxide entering our environments and entering the atmosphere, and it has been that way since the Industrial Revolution. Carbon dioxide is a gas which is created by a lot of different activities. Honestly, we create carbon dioxide by breathing. That's not really a problem because we have life, so plants, which help us filter out the carbon dioxide and the other problems in the air and create oxygen. The problem we have is we are putting too much into the system for it to actively filter it out correctly. So when we cut down trees, which naturally store carbon dioxide, when we have animal farts, yes, farts are funny. Cows
Cows are the really worst for this.
They are quite stinky and they also have a lot of methane. Because we have a lot of dairy farms and a lot of meat farms, cows fart a lot. And so it goes into our atmosphere. We also heat and cool our homes, so we can burn things like coal and other things for power, and that also increases the greenhouse gases. Now, the ocean plays a large role in helping to reduce the carbon dioxide. It absorbs gases into it and acts as a carbon sink, which means it stores the carbon dioxide gas, goes through a reaction, and it stores the bad pollutants in itself. And again, the problem is we're putting too much out for it to be able to handle it in the system.
If we go back to the experiment and use that as an example of what's happening to our planet, the water that we have here in the cup are our oceans, and then all of the bicarb vinegar is the carbon dioxide that we're introducing to the world. The lid that we put on top is that ozone layer, that layer across the world that we have there. But then when the carbon dioxide goes into the ocean is being affected by it. So we can see that by the changing of the colour in our water here. But we're going to talk a little bit later on about how exactly our oceans are being negatively affected by all of the carbon dioxide that we're adding to the atmosphere. Some of the damage that are caused or being caused by carbon dioxide in the oceans actually can't be reversed. One well-known way that this is affecting the oceans is the stagnation of coral and coral reefs. With a lot of CO2 in the ocean water, the coral skeletons haven't been growing as strongly as they were before climate change. Scientists have just learnt that carbon dioxide stops skeletons from thickening and becoming easily broken and damaged by waves, storms and hurricanes.
So with that and the phrase climate change, it will be pointed out that climate change has occurred naturally over the course of Earth's history. The issue with that is that climate change happened over the course of 10,000 years. And in the last 200 since the Industrial Revolution, we have done 10,000 years worth of change in 200 years.
One of the reasons why we've only just found out that CO2 is causing damage to coral and coral reefs is that because some coral are thousands of years old and sometimes only grow a few millimetres per year. Sadly, this actually means that the rate of new coral and coral growing is actually matching the rate of coral dying because of other effects of climate change. Coral reefs are really important as they support over 1,000 ocean species. They are especially important for fish because they use them to protect their young and their baby fish. One great example, and yes, I'm using this again, is Finding Nemo. At the beginning of the movie, you'll see all of the baby fish and other ocean life going to kindergarten within all of the coral reefs and just off of the coast of Queensland. So that just shows you an example of how important coral is for the world. If you haven't seen Finding Nemo, I've mentioned it twice in one of our STEAM Club videos. Please watch it, it's an awesome movie.
So what can we do to reduce the amount of carbon dioxide in the ocean? As Jasmine mentioned before, if carbon dioxide enters the atmosphere by cutting down trees, animal farts, heating and cooling homes, and vehicle fumes, that means we can reduce the amount of CO2 entering the ocean by reducing the amount of trees being cut down, use recycled paper and cardboard products.
Wait, hold on a minute.
Recycling mixed recyclables. We can reduce the amount of meat we eat. Have you heard of meat-free Mondays? You can also choose different types of meat because at times we farm a lot of cows when we have a natural source of meat available that is in abundance. So, looking with your parents at the ways you can reduce the cooling and heating costs of your home, maybe wearing more layers to keep warm, like sweaters and jumpers, increasing the insulation in your home. So you might be able to put more insulation in your walls, or you might be able to add things around the house on your windows to help heat and cool the home. You can reduce the amount of car travel you do, so you can walk or ride to your friend's house or the shops. You can park your car further away from school and walk the rest of the way. You can carpool, see if you and a friend are going to the same place at the same time and just to go together. Even buying locally grown fruit and vegetables helps with this, as they don't need to travel as far to be used and eaten. You can get reusable bags, as Jasmine had pointed out just then. So you're taking the same bags to the shops over and over and you get a long life cycle out of the bag. These small but simple things will affect the amount of CO2 in the oceans and help our coral survive, grow strong, and withstand more storms and damage. Thank you for watching. If you have our Science Week booklet, remember to answer our questions about this video, and we will see if you were really listening. Bye, and as always, remember, for science!
Dun, 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 dun.